Morning. I'm V.Srinivasa Reddy, Associate Professor of Mathematics, Government Degree College, Ramannapet, Telangana State. This is a 19th video lesson, but the 6th video lesson on geometry. Geometry sphere on sphere. This is 6th video lesson on sphere in geometry. Today I will talk on polar plane. So polar plane of a point to a sphere with respect to a sphere. When you say 2 points are conjugate points, when you say 2 lines are called conjugate lines, and we see some problems on tangent plane. In last class, I have we have seen tangent plane. We see some problems on tangent plane. So first, what is the meaning of a polar plane? Suppose a variable line. Suppose a line passes through a fixed point A and meeting given sphere, this line meeting a given sphere in P and Q. So if a line is drawn through a fixed point A here, meeting a given sphere in 2 points P and Q, and take a point R, is a point taken on this line such that we take a point on R on this line such that the points A, R divides this line AQ internally and externally in the same ratio. So such that the points A R divide this line internally and externally in the same ratio. Then the locus of this point R is a plane. This plane is called the polar plane of A with respect to the sphere, and this point A is called the pole of this polar plane, and here A is called the pole of this polar plane with respect to the sphere, with respect to the given sphere. So here polar plane means suppose a line drawn through a fixed point. This is a fixed point A. It meets this line intersecting the sphere or meeting the given sphere in P and Q. And take a point, and a point R is taken on this line, or is a point taken in this line, such that the points A, R divide this line, line internally and externally in the same ratio. So take a point R on this line such that the points A, R divide this line internally and externally in the same ratio. Then the locus of R is called it. Then the locus of point R is a plane. This plane is called the polar plane of A with respect to the sphere A. And the point A is called the pole of this polar plane. So here the points AR divides this line internally and externally in the same ratio. We'll get AR by AP same as AR by AQ. Because points AR divide this line internally and externally in the same ratio. That's why. So AR by AP is same as AR by AQ. So now locus of this point R is a plane. This plane is called the polar plane. So now polar plane of the point with respect to the sphere. X square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d equals 0 is S1 equals 0. So I'm writing directly. So polar plane of the point with respect to the sphere is S1 equals 0. And we know that S1 equals 0, x1 plus y1 plus z1. Just we take here coefficient of x is half u into x plus x1, and here half v into y plus y1 plus w and z plus z1 plus d equals 0. Same we can find like tangent plane. So tangent plane at a point is a S1 equals 0. Similarly, polar plane of the point at a point with respect to the sphere is also S1 equals 0. So polar plane means, so simply if a line passes through a fixed point A and take a point R in this line and it intersects the sphere at P and Q, take a point R in this line such that the points A, R divides the line internal external in the same ratio. That means here AR by AP equals AR by Q. Then the locus of R is called the polar plane of A with respect to the sphere, and this point A is called the pole of the polar plane. And also polar plane of the point with respect to the sphere is S1 equals 0. So find the pole of the plane Lx plus My plus Nz equal to P. With respect to the sphere x square plus y square plus z square equal to a square. Find the pole of the plane Lx plus My plus Nz equal to P. With respect to the sphere x square plus y square plus z square equal to a square. Let P is equal to x1 y1 z1 be the pole of the plane Lx plus My plus Nz minus P equals 0 with respect to the given sphere x square plus y square plus z square minus a square equals 0. So now we have to find here, find the pole of the plane with respect to this sphere. So here we have taken P is the pole of the plane with respect to sphere. Now we know already in the first, just now I have said, I told you, polar plane of at a point P is to the sphere is S1 equal to 0. That's why. So polar plane of P with respect to the sphere is S1 equal to 0. S1 equal to 0. So just xx1 plus yy1 plus zz1 minus a square equal to 0. Xx1 plus yy1 plus zz1 minus a square equal to 0. Now this is the pole of the polar plane of this point. Now actually pole of this plane is, this is polar plane. So now 1 and 3 represents the same equation because it is also a polar plane of this point. That's why. So 1 and 3 represents the same equation. So same equation. Therefore, so here x coefficient x1 by here x coefficient L is equal to here y coefficient is y1 by m. So here z coefficient is z1 by n is equal to minus a square by minus. So here 1 and 3 represents the same equation because so it is a polar plane of this point. Already we have taken pole of this plane means it is a polar plane of this point. So when we are saying it is a polar plane means at the point P means it is a pole. It is a pole. So here this is P is a pole of this plane means this is a polar plane of P with respect to sphere x square plus y square plus z square minus s square. You know this is S1 equal to 0 actually. So here we are getting x1x plus y1y plus z1z minus a square equal to 0. Now comparing 1 and 3, 1 and 3 represent same equation. It is a polar plane. It is a polar plane of P. So here x coefficient is the x1. Here L x1 by L same y1 by m z1 by n and minus a square by minus p. So finally we are taking these two x1 by L equal minus a square by minus p. Minus will be cancelled. X1 equal a square by L by p. Similarly, if you take these two y1 by m equal to minus a square by minus p, you will get so y1 equal to ma square by p and z by n equal to minus a square by minus p. You get similarly z1 equal to a square n by p. Therefore, required pole is p is equal to a square L by p, a comma a square m by p, a square n by p. So finally, pole of the plane with respect to the sphere is a simple. Here right side is a square L by p, a square m by p, a square n by p. Okay, simple. This is let p be the pole of this polar plane with respect to the sphere. We know that at p, actual polar plane at p is S1 equal to 0, xx1, yy1, zz1 minus a square equal to 0. These two represent same plane. So that's why x1 by L equal to y1 by m equal to z1 by n is equal to minus a square by minus p. Because here x coefficient is x1, y coefficient is y1, z coefficient is z1, and the constant is minus a square. So x1, y1, z1 minus a square. Here L, m, n minus. So finally we are getting, if you take these two, we'll get x1 equal to a square L by p. y1 equal a square m by p, z1 equal a square m by p. So required pole is a square by L, a square L by p, a square m by p, a square. So when you say 2 points are consequent points. So suppose P and Q are 2 points. If the polar plane of one point say P passes through the another point say Q, then the 2 points P and Q are called conjugate points. So when you say 2 points are conjugate, if the polar plane of one point is passes through the another point, then the 2 points are called the conjugate points. So when you say 2 points are called conjugate, if the suppose 2 P and Q are 2 points, if the polar plane of a one point P passes through another point Q, then the 2 points are called conjugate points. So simple conjugate point means, so the polar plane of one point passes through another point, then the 2 points are called the conjugate points. Polar lines means similarly. Polar lines means two lines, if you take two lines such that the polar plane of every point, the polar plane of every point on either, so if you take any one, the polar plane of every point on one line, either means one line, passes through the other line called polar lines. Suppose the L1, L2 are two lines. So two lines L1, L2 are called polar lines. If the polar plane of every point on one line, say L1, passes through another line L2, then the two lines are called the polar lines. Simply we say that two lines are called polar lines if the polar plane of every point on one line passes through the other is called the polar lines. So we see one problem on polar lines. So that the polar line of x plus 1 by 2, y minus 2 by 3, z plus 3 with respect to the sphere x square plus y square plus z square is the line 7x plus 3 by L 11, 2 minus 7 by y by 5, z by minus 1. So show that the polar line of with respect to the sphere is the line 7x plus 3 by 11, 2 minus 7 by y by 5, z by minus 1. So any point on the line is, any point on this line for a given line, x plus 1 by 2, y minus 2 by 2, z plus 3 equal t. So from this we get x plus 1 equal 2t, y minus 2 equal 3t. If you take this 2, z plus 3 equal to t. So finally we are getting x equal 2t minus 1. So x plus 1 by 2 equal t implies x plus 1 equal 2t. So that means x equal 2t minus 1. And y minus 2 is equal to 3t. We'll get y is equal to 2 plus 3t. Z plus 3 equal to t implies z equal to t minus 3. So now finally any point on this line is, any point on this line is of the form 2t minus 1, 2 plus 3t, t minus 3. So any point on this line is of the form t is equal to 2t minus 1, 2 plus 3t, t minus 1. So finally, any point on the line x plus 1 by 2, y minus 2 by 3, z plus 3 is a 2t minus 1, 2 plus 3t, 2 minus 3. How can we get? Is equal to t, say x plus 1 equal to 2t, that is x equal to 2t minus 1. Similarly, y is equal to 3t plus 2. Similarly, z equal to t minus 3. Now we have to find the polar plane at this point. So this is a x1, y1, z1. So polar plane is s1 equal to 0. So polar plane of P with respect to sphere is s1 equal to 0 means x square plus y square plus z square minus 1 equal to 0. S1 equal to 0 means here S1 is 0 means xx1 plus y by 1 plus zz1 minus 1 equal to 0. So xx1 plus y by 1 plus zz1 minus 1 equal to 0. So here x1 is 2t minus 1, y1 is 2 plus 3t, z1 equal to t minus 3. So we will get, so x1 equal to 2t minus 1. This is y1 is 2 plus 3t, z1 equal to t minus. So here you observe, here minus 1 is missed. I have to write minus 1. Here minus 1 I have to write. Here we have to write minus 1. So x into 2t minus 1, y into 2 plus 3t, z into 2 minus 3, minus 1 equals 0. Minus 1 is missed. So finally we get minus x plus 2y minus 3z and minus 1. It is missed, minus 1. So minus x plus 2y minus 3z minus 1. Taking t common, here 2tx, here 3y here z t common, 2x here 3y and plus z equal to 0. So here minus 1 is missed, xx1 plus y by 1 plus zz1 equal to minus 1. So we can write here x into 2t minus 1 plus y into 2 plus 3t, z into 2 minus t minus 3 minus 1 equals 0. So now minus x plus 2y minus 3z minus 1. Here minus 1 missed. This minus 1 is missed. So I have written here minus 1 plus t into 2x plus 3y plus z. Therefore, polar line of given line with respect to given sphere is minus x plus 2y minus 3z minus 1 equals 0. And another one is 2x plus 3y plus z equals 0. Here minus 1 is missed. Minus 1 equals 0. We have to write. So x into 2t minus 1, y into 2 plus 3t, z into t minus 3 minus 1 equals 0. So minus 1. So minus x plus 2y plus 3z minus 1 plus t into 2x plus 3y plus z equals 0. So therefore, polar line of given line with respect to given sphere is, so minus x plus 2y minus 3z minus 1 equals 0, 2x plus 3y plus z equals 0. So this is the symmetric form of the line. This is the symmetric form of the line. So now we have to change it's unsymmetric form of this line. Now we have to change it into symmetric form. So let z equal 0. Z equal 0 will get minus x plus 2y minus 1 equals 0. So it is unsymmetric form of the line. So we change into symmetric form. Taking z equal 0, we'll get minus x plus 2y minus 1 equals 0. And 2x plus 3y equals 0. So now we have to solve for xy here. So 2 into 3. 2 into 3 plus 4. So here first we have to x cancel. Here if you do multiplying by 2, we'll get minus 2x plus 2x will be cancelled. 2 into 3 plus 4. So 4y plus 3y, 7y. Here 2 into 2 means 2 into 3 means minus 2 is equal to 0. So 7y equal to minus 2 to 0, y equal to 2y. So and by 3, x equal to x, if you take the right side, x equal to 2y minus 1, we'll get y is 2 by 7, 4 by 7 minus 1, that is 4 minus 7 by 7, that is minus 3 by 7. So finally, the point of intersection is we will get minus 3 by 7, 2 by 7, 0. So this is unsymmetric form, minus x plus 2y minus 3z minus 1 equals 0, 2x plus 3y plus z equals 0. So taking z equals 0, we will get minus x plus 2y minus 1 equals 0, 2x plus 3y equals 0. So 7y minus 2 equals 0, y is equal to 2 by 7. So x equal to 2y minus 1 means 4 by 7. 4 by 7 minus 1, that is a 4 minus 7 by 7, that is minus 3 by 7. So let Lmn be direction ratios of line. Direction ratio of this line, then automatically, because minus 1, 2, minus 3 are normal. So these two are perpendicular. That's why minus L minus plus 2m minus 3n. A1, A2 plus B1, B2 plus C1, C2 equals 0. Because the minus 1, 2, minus 3 is normal to the line. And 2, 3, 1 also normal to the line. That's why we'll get 2L plus 3m plus n equals 0. Now we have to find the element from these two equations. Just simple, right? First m coefficient 2, then n coefficient minus 3, then L coefficient, then m coefficient. So similarly, here m coefficient 3, n coefficient 1, L coefficient, and m coefficient. So observe. First write m coefficient 2, n coefficient minus 3, n coefficient, L coefficient minus 1, and m coefficient. Similarly, m coefficient 3, n 2, L coefficient 3. So first you write m coefficient 2, then n coefficient minus 3, then L coefficient minus 1, then m coefficient. So 2 minus 3 minus 1. Similarly, 3, 1, 2, 1. First write m coefficient, then write n coefficient, then write L coefficient, then write m coefficient. So first write m coefficient 2 minus 3 minus 1, 2. So I have written 2 minus 3 minus 1, 2. Similarly, start here m coefficient 3, 1, 2, 3. 3, 1, 2, 3. Right here L, m, n. So L by 2 into 1, 2 minus, so like AD minus B. So 2 into 1, 2 minus of minus. Minus 3 into 3, but minus of minus 9 plus 9, 2 plus 9. M by minus 3 into 2, minus 6. So minus of minus 1 into 1 plus 1. Minus 1, minus of minus 1 is plus 1. Here minus 1 into 3, minus 3. Minus 2 into 2, minus 4. Here we are getting plus because minus of minus 1. So minus of minus 1. So finally we are getting, so here 2 minus of minus 9, because of minus 3 into 3 is minus 9. That's why 2 plus 9. So minus 6 plus 1, minus 7 minus 4. Finally get L by 11, M by minus 5, N by minus 7. So that means this line passes through, already we have point of intersection. X is minus 3 by 7, Y is 2 by 7, Z 0, Z 0. So this line passes through minus 3 by 7, 2 by 7, 0. And the direction ratios are proportional to 11 minus 1 minus 7. So equation of polar line, required equation of polar line is, we know that a line passes through x1, y1, z1 with the direction ratios 11 is x minus x1 by l, y minus y1 by n, z minus z1 by n. Here x1, y1, z1 is x1 is minus 3 by 7, y1 is 2 by 7, z1 is 0. So we write x minus x1 means x plus 3 by 7. Here y minus 2 by 7. So z minus 0, z is 0 is z is 0. So finally we are getting x plus 3 by 7 by L is the 11 proportional to L. So minus 5 minus. So finally get 7x plus 3 by 77. 2 minus 7y by. So writing minus numerator, you get minus minus plus 2 minus 7y by 35. Here 7y minus 2. But taking minus the numerator, you get 2 minus 7y by 35, 7 into 5, 35, z by minus. So 7x plus 3 by dividing by 7, we'll get 7x plus 3 by 11, 2 minus 7 by 5, z by minus. This is the required line. So here you observe, your minus 1 is missing. So here we have tried to minus 1 equals 0. That's why minus x plus 2y minus 3z minus 1 plus 3 into 2x plus 3y plus z. Here this minus 1, here is. So I have written here minus 1. Okay. So this is unsymmetric form of the line. So this is unsymmetric form of the line minus x 2 plus 2y minus 3z minus 1 equals 0. 2x plus 3y plus z equals 0. In the answer given symmetric form, that's why first I have to find point of intersection and direction. For the point of intersection, that z equals 0. So we'll get minus x plus 2y minus 1 equals 0, 2x plus 3y equals 0. So solving these two equations, we'll get, so to solve this, here 2x is that multiplying by 2 minus 2x, 2x will be cancelled. 2 of into 2y, 4y plus 3y, 7y. 2 into minus 1 minus 2 equals 0. We'll get y equal to 2 by 7. From this, x equal to 2y minus 1. You get 4 by 7 minus 1, that is 4 minus 7 by 7, that is minus 3 by 7. So let element be direction ratios. From this, we'll get. Here, just write first m coefficient, 2 minus 3 minus 1, m coefficient, n coefficient, L coefficient, m coefficient. Same. 3, 1, 2, 3. Okay. From this, we can find element and then we write the equation of the polar line. See, two problems on tangent planes. Find the two tangent planes. Find the two tangent planes to the sphere x square plus y square plus z square minus 4x plus 2y minus 6z plus 5 equals 0, which are parallel to the plane 2x plus 2y equals z. So find the two tangent planes to the sphere x square plus y square plus z square minus 4x plus 2y minus 6z plus 5 equals 0, which are parallel to the plane 2x plus 2y equals z. So we know that the condition for a plane is tangent is the radius of sphere equal to the perpendicular distance from the center of sphere to the plane. So using that condition, we can find the values, we can find the tangent planes. First, right, given sphere is x square plus y square plus z square minus 4x plus 2y minus 6z plus 5 equals 0. Now compare this equation with general equation. You know general equation, x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d equals 0. So comparing this equation, we get 2u is equal to minus 4, 2v is equal to 2, 2w equal to minus 6, and d is equal to 5. So x coefficient is 2u minus 4, y coefficient is 2v, 2, z coefficient is 2w is equal to minus 6, and d is equal to 5. So from this, u is equal to minus 4 by 2 minus 2, v is equal to 2 by 2, 1, w is equal to minus 6 by 2, minus 6 by 2 means minus 3, d is equal to 5. So first I will find center of sphere. We know the center of sphere formula, center of sphere equal to c is equal to minus u minus v minus w. So here u is minus 2. So we can write minus u means 2, minus v means minus 1, minus w means 3. So finally we are getting 2 minus 1, the center of the sphere. So now radius of sphere. We know the formula for radius of sphere for general equation, for this general equation. We know that root of u square plus v square plus w square minus t. So radius of sphere equal to root of u square plus v square plus w square minus t. So what is u? U here minus 2. U square means minus 2 whole square is 4. V square 1 square 1. W square minus 3 whole square is plus 9 because minus 3 into minus 3 will get plus 9. Minus 1 whole square minus 3 whole square means so minus whole square is plus 3 square means 9. So under D is 5 minus 5. So finally we are getting 4 plus 1, 5, 5 will be cancelled. We get 14 minus 5, 9. So finally we get 3. So finally we are getting the radius of sphere. We can find radius of sphere by the formula root of u square plus v square plus w square minus 3. So we'll get root of 4 plus 1 plus 9 minus 5. That is root 9 that equal to 3. So we know formula for center of sphere is the minus u minus v minus w. And radius of sphere is the root of u square plus v square plus w square minus 3. This already I told you in the first class. So this is the center of sphere and radius sphere. Now, what is the question? He has given question asked, find the two tangent planes to the sphere which are parallel to the line, which are parallel to the plane 2x plus 2y is equal to z. You know that the any plane parallel to the, suppose any plane parallel to some ax plus by plus cz plus d equals 0 is ax plus by plus cz plus k equals 0. So now equation of the plane parallel to the plane 2x plus 2y minus z equals 0 is simple, right? Just simple 2x plus 2y minus z plus some k equals 0. Because these two are parallel, that's why direction is normal same. That's why I have written here 2x plus 2y minus z and write some k, constant k equals 0. So we know that the equation of the plane which is parallel to the plane ax plus by plus cz plus d equals 0 is ax plus by plus cz plus k equals 0. So we can write for 2x plus 2y minus z equals 0 is 2x plus 2y minus z plus k equal to 0. So now we have to find the value of k. How can we find the value of k? How can we find the value of k? So this plane is a tangent to the given sphere. So in question asked what of what can we find? Find the two tangent planes to the given sphere which are parallel to this line. Now this line is a tangent plane to this sphere. When it is a tangent plane, so now this line, so this plane is a tangent plane to the given sphere. So plane 1, plane 2, this plane 2x plus 2y minus z plus k equals 0 is a tangent plane to the given sphere. So what is the condition for a tangent? A plane is a tangent to a sphere. Its condition is radius of sphere equal to perpendicular distance from center. Center is here. Center is a 2 minus 1 3 to the from the center of sphere to the given plane 2x plus 2y minus z plus k to the plane 2x plus 2y minus z plus k equals 0. Already I find what is the radius of sphere. Radius of sphere is 3. So 3 equal to, now we have to find the perpendicular distance from the point 2 minus 1 3 to the plane 2x plus 3y minus z plus k equals 0. We know perpendicular distance from the point x1, y1, z1 to the plane ax plus by plus cz plus d equals 0 is ax1 plus by1 plus cz1 plus d by root of a square plus b square plus c square. So just write perpendicular distance is simple. Write this point here x equal to 2, y equal to minus 1, z equal to 3. So 2 into 2, 2 into minus 1, minus 3 plus k by. Write this point here. So ax1 plus by1 plus cz1 plus d by root of a square. A square means x coefficient square. 2 square is 4. And plus b square. Y coefficient is 2 square is 4. Z coefficient square. Plus minus 1 whole square is plus 1. Minus 1 whole square is plus 1. So what is the formula? Perpendicular distance from a point x1, y1, z1 to the plane ax plus by plus cz plus d equals 0 is ax1 plus by1 plus cz1 plus d by root of a square. A square means x, coefficient of x square plus b square means coefficient of y square plus c square means coefficient of z square. So that's why we have written here, just write simple, just write this point x equal to y equal to minus 1 equal to 3 by square root of coefficient of x is 2 square is 4, coefficient of y 2 square 4, coefficient of z is minus 1 whole square, minus 1 whole square is plus 1. So finally we are getting 2 into 2 is 4, 2 into minus 1 minus 2, minus 3 plus k. So finally we are getting here 4 minus 5, plus k. So finally we are getting mod k minus 1 equal to 9. Mod k minus 1 equal to 9. So here ax1 plus by1 plus cz1 plus d by root of a square plus b square plus c square. Just simple write this point in the on this line. Write x equal to 2, y equal to minus 1, z equal to z equal to 3. Root of a square, 2 square plus 2 square plus minus 1 whole square. Minus 1 whole square is 1. So finally we are getting 4 minus 2 minus 3 plus k by 3. We are getting mod k minus 3 into 3. 3 into 3 is 9. So mod k minus 1 equal to 9. So what is the mod x equal to? Mod x equal to some a means x equal plus or minus c. So mod k minus 1 equal to 9. That's why k minus 1 equal to plus or minus 9. So k minus 1 must be equal to plus or minus 9. So if you take my k minus 1 equal to 9 is also 9. K minus 1 equal to minus 9, you can get mod minus 9 is plus 9. So suppose k minus 1 equal to 9. What happens? K is equal to 9 plus 1, 10. So suppose k minus 1 equal to minus 9. So k is equal to here, so minus 8. It is missing here, minus 9 plus 1. Let write minus 8. So you have to write here k is equal to, mistaken here, k is equal to minus 8. K is equal to 10 or minus 8. Here we have to write minus 8. Minus 8. So the four required tangent planes are 2x plus 2y minus z plus 10 equal to 0, 1. And another one is 2x plus 2y minus z minus 8 equal to 0. 2x plus 2y minus 8 equal to 0. So here mistaken. Here 2x plus 2y minus z plus 10 equal to 0. 2x plus 2y minus z minus 8 equal to 0. Here minus 8. Here minus 8. So here minus 8. Because k is equal to minus 9 plus 1. So we have to rough it and you can write k is equal to minus 8. So finally we are getting 2x plus 2y minus z minus 8 equal to 0. Minus 8 equal to 0. And 2x plus 2y minus z plus 2. So the four equations of tangent planes which are parallel to 2x plus 2y equal to z are 2x plus 2y minus z plus 10 equal to 0, 1. Another one is 2x plus 2y minus z minus 8 equal to 0. So just find the center and the radius of given sphere. And we know that the parallel to given plane is a 2x plus 2y minus z plus k equal to 0. 2x plus 2y minus z plus k equal to 0. So just apply the condition for tangent, radius of sphere. The condition of tangent plane to the sphere is a radius of sphere equal to perpendicular distance from the center of sphere to the plane. You can write 3 equal to perpendicular distance is ax1 plus by1 plus cz1 plus d by root of a square plus b square plus c square. Just write this point x equal to 2, y equal to minus 1, z equal to 3, and root of a square 2 square, 2 square plus minus 1 whole square. That is 4 plus 4 plus 1. So finally we are getting mod k here 4 minus 5 minus 1, k mod k minus 1 equal to 9. K minus 1 equal to plus or minus 1. We'll get k is equal to 10. K minus 1 equal to 9. K equal to 10 are here. K is equal to minus 1. So get that k is equal to minus 8. So finally get the answers 2x plus 2y minus z plus 10 equal to 0. Here 2x plus 2y minus z minus 8 equal to 0. See another problem. Find the equation of sphere which touches the sphere at 1, 1 minus 1 and passes through origin. Passes through. So now we have to find the equation of sphere which touches the sphere at the point 1, 1 minus 1 and passes through origin. So first, tangent plane to the given sphere x square plus y square plus z square minus x plus 3y plus 2z minus 3 equal 0 at 1, 1 minus 1 is S1 equals 0. You know that the tangent plane to the sphere at a point x1, y1, z1 is a S1 equals 0. Just S1 equals 0 means xx1 plus yy1 plus zz1. So here x coefficient is minus 1, right of minus of x plus x1, and similarly right a coefficient of y is 3. Half of the 3 is 3 by 2, 3 by 2 y plus y1, and then right the half of the coefficient of z is a 1 by 2, 2 by 2 is 1, so that's why z plus z1 minus 3 equals 0. So simple right to write a tangent plane to a sphere at a point is S1 equals 0. S1 equals 0 means x1 plus y1 plus z1. Just write here coefficient of x off. So minus 1 is there. I have written minus of x plus x1. And coefficient of y off 3 by 2, y plus 1. Coefficient of z of 1 by 2 of 2 is 1. That's why z plus z1. 1 into z plus z1. Minus 3. D is minus 3 equals 0. So here point is what is x1 here? X1 equal 1, y1 equal 1, z1 equal minus. So we can write x into 1 x, y into 1 1 y, z into minus 1 minus z. So here x1 is 1, y1 is the minus, y1 is equal to 1, z1 equal to minus 1. So x1 is 1x equal to x, 1y equal to y, minus 1 into z equal to minus z. So minus of x1 is x1, y1 is 1, z1 is a minus 1. So minus 3. Finally, we are getting z will be cancelled. We'll get here multiplying by 2, we'll get 2x multiplying by 2. We'll get what we'll get 1 by 2, 2x plus 2y. So 2 will be cancelled, minus x minus 1. Here 2 will be cancelled, 3 plus 3y plus 3. And this minus 2 plus 2 will be cancelled, minus 1 minus 3. So here 3y plus 3, here minus 1 minus 3 minus 4 into 2 minus 8, minus 4 into 2 minus 8. Here multiplying by 2, 2x plus 2y minus x minus 1, and multiplying by 2, 3y plus 3. Here 2 cancel, minus 1 minus 3 minus 4 into 2 minus 4 into 2 minus 8. So finally we are getting 2x minus x, 2y plus 3y, 5y. So minus 1 plus 3 minus 8. So minus 9 plus 3 minus 6 equals 0. So therefore, now we have to find the equation of sphere which touches the given sphere at a point 1 minus. So now equation of required sphere is s plus lambda of equal 0. So that means given sphere passes through the required sphere is passes through the given sphere on the tangent plane. So that's why I have written s plus lambda of equal 0. This is tangent plane phi equal 0. So x square plus y square plus z square minus x plus 3y plus 2z minus 3 s plus lambda phi. So lambda phi is this is x plus 5y minus 6 equal 0. So now we have to find out the value of lambda. Given condition, it passes through origin. Origin means x 0, 0, 0. 0, 0, 0. X equal 0, y equal 0. Substitute x 0, y 0. Passes through origin means 0, 0, 0. So 0, 0, 0, 0 minus 3 plus lambda 0 plus 0 minus 6. So finally we are getting minus 3 minus 6 lambda equal 0. We'll get minus 3 equal 6 lambda. Lambda equal to minus 3 by 6. That is lambda is equal to minus 3 by 6. We'll get lambda is equal to minus 3 equals 6 lambda. Since it passes through origin, that means x0, y0, z0. So we'll get minus 3 minus 6 lambda equals 0. Minus 3 equals 6 lambda. So finally we are getting lambda is equal to minus 3 by 6. That equal to minus 1 by 2. Therefore, required equation is substituting 1 by 2. Lambda equal to minus 1 by 2. We get so x square plus y square plus z square minus x plus 3y plus 2z minus 3 minus 1 by 2. X plus 5y minus 6 equals 0. So simplifying, so cross multiplication of 2 will get 2x square plus 2y square plus 2z square. Here minus 2x minus 6. Minus 2x minus x minus 3x. And 2 into 3y, 6y minus 5y. 6y minus 5, y. 4z plus 4z. Minus 3 plus 3 will be cancelled. So here substituting lambda equal to minus 1 by 2 in the equation 1. So we'll get x square plus y square plus z square minus x plus 3y plus 2z minus 3 minus of x plus 5y minus 6 equal to. So we'll get cross multiplication of 2x square plus 2y square plus 2z square is a minus 2x plus 6y plus 3z. Minus 2x minus x is minus 3x plus 6y minus 5y plus y. 2z plus 2z into 2, 4z. So here minus 6, we get plus 6 cancel. Finally, we get 2x square plus 2y square plus 2z square minus 3x plus y plus 4z equals 0. So this is a required plane. Just first I find a tangent plane to the given sphere at the point s1 equals 0. Just substitute x1, y1, z1. Here take coefficient of x is half, 1 by 2, x plus x1. Here half is 3 by 2, y plus y1. Here half is 2 by 2, 1. That's why z plus z1 minus 3 equals 0. Just write x1 equal to 1, y1 equal to 1, z1 equal to minus 1. Substituting this, we'll get x plus y minus z. So z1 is minus 1 by 2 x plus 1 plus 3 by 2 y plus 1 plus z minus 1. Z will be cancelled. Finally, we get 2x plus 2y minus x minus 1 plus 3y plus 3 cross multiplication by 2. Minus 1 minus 3 minus 4 into 2 minus 3. So finally, we'll get x plus 2x minus x is x plus 5y minus 6 equals 0. So now required sphere is a passes through the, because it touches the given sphere, passes through given sphere and this tangent plane. So therefore, s plus lambda of equals 0. Just substitute x 0. It passes through origin. Substitute x equals 0, y equals z equals 0. We'll get lambda value from this. Substitute the lambda value. So finally get the answer. This is the today's class. A class polar plane of a point with respect to the sphere is s1 equals 0 and polar plane lx plus my plus z equal p is x with respect to the sphere x square plus y square plus s square is a square l by p y s square m by p s square m by p. So 2 points are conjugate points. If the polar plane of one point passes through another plane, then the 2 points are called the conjugate points. Polar lines means the polar plane of every point on one line is passes through the other line. Then the lines are called the polar lines. Thank you.